Cosmic secrets revealed. Beyond time, beyond space, beyond imagination.
Have you ever stared up at the night sky and wondered what's really out there? Beyond the stars we can see, lurking in the shadows of the cosmos, are monsters so massive they defy our very understanding of the universe. We're talking about black holes, but not just any black holes. We're diving deep into the realm of the giants. Supermassive black holes billions of times heavier than our own sun. These are not your everyday cosmic phenomena. These are titans capable of swallowing stars, planets, and even entire solar systems whole without so much as a cosmic burp. They are the silent rulers of galaxies, shaping the very fabric of space and time around them. So, strap in and prepare for a journey to the edge of reality. In this video, we're going to count down and explore the absolute largest, most mind-boggling black holes ever discovered. You think you know big? You have no idea. So, what exactly makes a black hole big? It's not just about its physical size, because technically, a black hole's mass is crushed into an infinitely small point called a singularity. Instead, we measure their size in two main ways: mass and the event horizon. Most black holes we know about are called stellar mass black holes. They form when a single massive star, many times larger than our sun, reaches the end of its life and collapses under its own immense gravity. It's a dramatic, explosive end that leaves behind a gravitational pit. But supermassive black holes? They're a completely different beast. These behemoths grow over billions of years, lurking at the centers of galaxies. They act like cosmic vacuum cleaners, relentlessly devouring gas, dust, stars, and anything else unlucky enough to stray too close. They also grow by merging with other black holes, getting bigger and bigger with each collision. When we talk about their size, we often refer to the event horizon. Think of it as the ultimate point of no return. It's the boundary around the black hole, where gravity becomes so powerful that nothing, not even light, can escape. The more massive the black hole, the larger its event horizon. For some of the giants we're about to discuss, their event horizons are so vast they could swallow our entire solar system many times over. Let's start our cosmic tour with a black hole that's relatively close to home. At the very heart of our own galaxy, the Milky Way, lies Sagittarius A, pronounced Sagittarius A star. Now, don't get me wrong, calling it small is a bit of an understatement. This supermassive black hole has a mass equivalent to about 4 million suns. That's 4 million of our stars crushed into a single point. For decades, astronomers observed stars at the galactic center whipping around an invisible object at incredible speeds. The only explanation was a supermassive black hole, and in 2022, the Event Horizon Telescope collaboration finally gave us a direct image, confirming its existence beyond any doubt. Compared to the other giants on our list, Sagittarius A is actually quite calm right now. It's not actively feasting on huge amounts of matter, which is probably a good thing for us. But don't let its current tranquility fool you. Its immense gravitational pull is the anchor for our entire galaxy. Every star, including our sun, orbits this central giant. It's the silent master that dictates the structure and motion of the Milky Way. Now let's step up the scale significantly and travel 55 million light-years away to the Virgo galaxy cluster. Here, we find the galaxy Messier 87, and at its heart, a true monster, M87 Caus. This was the very first black hole ever to be directly imaged by humanity, a groundbreaking achievement that gave us our first real look at one of these cosmic enigmas. And what a sight it was. M87 is a behemoth, clocking in at a staggering 6.5 billion times the mass of our sun. If Sagittarius A is a king, M87 Tak is an emperor. Its event horizon is so large that our entire solar system would fit comfortably inside it. But what makes M87 Tak truly spectacular isn't just its size, it's its power. This black hole is an active galactic nucleus, meaning it's furiously consuming matter. As gas and dust spiral into its gravitational maw, they're superheated and form a brilliant accretion disk. Even more impressively, M87T shoots out a colossal jet of high-energy particles that travels at nearly the speed of light. This jet is so powerful that it extends for over 5,000 light-years, stretching far beyond the confines of its own galaxy. It's a stunning display of the raw, destructive, and creative power that these giants wield. If M87T is an emperor, then our next destination is home to a cosmic god. Prepare to meet the true Titan, the current record holder for one of the most massive black holes ever found. TON 618. Located about 10.4 billion light-years away, this object is so distant that we're seeing it as it was in the early universe. TON 618 is not just a black hole, it's a quasar, which means its accretion disk shines with the light of trillions of stars, making it one of the brightest objects in the entire known universe. But the light is just a side effect of the monster hiding within. The black hole at the center of TON 618 has an estimated mass of 66 billion, that S billion with AB, times the mass of our Sun. To put that into perspective, it's over 15,000 times more massive than Sagittarius A in our own galaxy. Its event horizon is absolutely colossal. If you were to place TON 618 where our Sun is, its event horizon would engulf not just Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, but also the Kuiper Belt, and extend far out into the Oort cloud. It would take light weeks to cross from one side of it to the other. TON 618 is a humbling reminder that the universe operates on a scale that is almost impossible for our minds to fully grasp. So, the big question is, how on earth do these things get so big? A black hole with the mass of 66 billion suns can't just be born from a single star. The leading theory is a process called hierarchical merging. It all starts in the early universe. The very first stars were much more massive than the stars we see today. When they died, they formed the first seed black holes, which were still relatively small, maybe hundreds or thousands of times the mass of the Sun. From there, it's a cosmic feeding frenzy that lasts for billions of years. These seed black holes, located at the centers of infant galaxies, began to pull in surrounding gas and dust, growing steadily. But their main source of growth came from mergers. As young galaxies collided and merged to form larger ones, a common process in the early universe, their central black holes would spiral towards each other and eventually combine, creating an even more massive black hole. Imagine two galaxies crashing together, and at the end of the cosmic dance, their two central black holes become one. Repeat this process over and over for billions of years, and you get a giant like M87T, or a Titan like TON 618. They are the ultimate cosmic cannibals, sitting at the gravitational heart of their galaxies, their growth inextricably linked to the evolution of the galaxies themselves. From the relatively familiar core of our own Milky Way to the blinding light of quasars in the distant past, the biggest black holes in the universe are the silent rulers of the cosmos. They are objects of incredible paradox, points of infinite density surrounded by a boundary from which nothing can escape. They can destroy stars, solar systems, and anything that crosses their path. Yet, at the same time, they are fundamental architects of the universe. Their immense gravity holds galaxies together, and their powerful outflows can trigger or halt the formation of new stars, shaping the destiny of the galaxies they inhabit. These giants, like TON 618, M87T, and even our own Sagittarius A, are more than just cosmic curiosities. They are profound reminders of our own place in the universe. They show us that the cosmos is more vast, more extreme, and more mysterious than we could ever have imagined. Exploring them pushes the limits of our knowledge and technology, forcing us to ask deeper questions about gravity, space, time, and our own origins. We may never visit one, but by studying them, we get a glimpse into the very heart of creation and destruction. Thanks so much for joining me on this journey to the edge of space and time. If you found this as mind-blowing as I did, don't forget to hit that like button and subscribe for more deep dives into the wonders of our universe. Let me know in the comments which cosmic mystery you'd like to explore next. Until then, keep looking up.